Okay, so this is milestone 1 for the game known as ParticleKnight, a shooter game. Here I'm going to show the functions of the character root motion. I'm going to show you real quick that I do have the appropriate animations for the character in the level. It came with 4 different types of animations. One is for the charge, which is basically a run animation. We have the idle animation, which makes it so when a player is not moving, it shows an idle animation. We also have the regular walk animation for the character, and we also have the attack animation for whenever the player makes an attack. I'm going to showcase a little bit of gameplay with the character. So as you can see, the character is still idle, and this is the appropriate animation that is played. But when it gets to move, this is the appropriate move animation along with the appropriate attack animation. And of course we also have the sprint animation for whenever the character is running. As you can see, the camera is also following behind the player appropriately. In addition to that, we also have the mouse movement, how it appropriately rotates the character and by the movement of the mouse. Going over to the next piece of thing that we have is the mouse is being traced by the Raycast from the camera. What that does is it basically forms a line between the character object and the mouse via appropriately through the scene plane, X and Y. And this type of level that we have here is supposed to be based on a story that we have a lonely knight who went through a serious amount of training, and this is based off the fact that it can attack based on the Black Panther movie, how we have the Black Panther's allied forces able to shoot projectiles via specific weapons that they have. That's the inspiration behind the attack animation, how it fires an orb for our ParticleKnight. As well as the fact that the ParticleKnight is able to sustain a huge number of attacks because of the insane amount of training that he has. Another inspiration based on the Black Panther Soldiers movie that you see via today. So now to go over a bit of the coding that I had for the project. I'm just going to go over the how the player camera is set up. I have this set up here is through usage through the lock state for the camera, so we're making sure that we're not going crazy with the mouse and seeing that the mouse gets wandered off through a distance. This is the changes that I made for the viewpoint of the camera. So what we have here is that we have a mouse sensitivity already set. We also have a reference to the character, and we always take in the transformation, and we also lock the cursor. So what this does is that once we clicked into the game, it makes it so that the mouse is shut off and it doesn't get to wander off, and you still maintain control of your character. And what the rotate function does is that it makes it so that it senses the sensitivity, and the vector up is only going to be the we're only moving the Y rotation, which what that means is that we're fixing the Y-axis of the object, and based on the X of the mouse is basically the rotation, how far we want to rotate through the X-axis of that. It's like a top that we're pinning down and we're spinning it around. That's how I'm making the camera function for the rotation, for the control of the camera, excuse me. Next thing that I have to showcase here is player movement. What I have set up for player movement is a lot of things that has to relate to how the camera is. It has to do with how the character controller and animations working, as well as how high the character is jumping, the effects of gravity, the ground mask, which is a layer mask that I place within the level. I'll showcase that in a bit. I also have a check for the ground distance and a boolean if it's grounded. I also have the speeds of movement, walk, and run. We also have constant update of the start routine of the attack. And what this start coroutine does is it also checks for animations that the character object has stored. And we do that based with the anim component. Then what we do is once at the moment that we do the movement, we go to here, then it double checks if we're grounded at all. It also places a trace in the level. You're gonna see it in a bit. Then the check is performed if we're grounded and our vector and our velocity y is less than 0, then we say -2. So that way that we're constantly descending and we're not we're always moving down. We also have I placed in two values for X and Z. And the reason why we only want X and Z is because the Y, it controls how high it is and how low it is for our character. So then once we get the appropriate values, we store in that specific value for X via the horizontal. And the horizontal are the inputs that you get to call upon from Unity. The vertical, we chose it to be for Z movement. It's based on the vertical. And the vertical is basically our up and down movement. This is what I've used for our character movement, and it functions fluently more better than the and we use the move direction. The move direction, it takes in a new vector 3 and it will place in the movement based on how far we moved with our X and Z. Our Y is always going to be 0 because that's because we have not jumped, we have not performed any kind of action that allows us to either go up or lower from where we are in the level. Once we get this move direction, then we put it back into this move direction transform, and it'll constantly be applied there. And then if we are grounded, it performs 4 different checks. If our move direction does not equal vector 0, then we and we have not pressed the left shift button, which is the button assigned for sprinting, then it's just going to perform the regular walk animation. For running, it's going to be played if we have pressed and hold, if we have pressed the left shift button. Else, if we didn't do anything of that, but our move direction vector is if our move direction is the same as vector 0, then we remain idle. Then the movement speed, how far we move, is based on how fast we get to move based on our speed. Then that loops back to the controller move based on time delta time. But at any point, if we press the jump button, then we get to do the jump. Then the velocity will always be controlled by gravity multiplied by time delta time. Same goes for the movement based on velocity multiplied by time delta time. Each one of the ones that are called walk, run, idle, and jump are all different private void places, modules that it sets an animation for each one appropriately. And this is how fast we want the animations to go, so that it shows that the animation is running fluently and smoothly. Same goes for run. And here we have the attack enumerator. So we have the attack layer, and it's always going to call the appropriate attack layer. Then we also wait for a couple of seconds before we run back to regular idle loop animation. The next is the appropriate coding for the camera. That is also stored within the projectile sword. This is the script that I've decided to name it as projectile sword. There is another good example of projectile cameras that I was able to take a look at. So how I named it is that we have a reference to a game object of a bullet. We also have the appropriate booleans for how much force we're applying to the game object that we're shooting. And there's two separate ones, so we can apply the upward one if we want to. And then we have the appropriate stats for the projectiles. We have time between shooting, how much spread we can have, the reloading time, the time between shots, the integers with magazine size and bullets per tap, and the boolean if we want to hold on to the button or not. That's also up to the designer if they want to edit that. And then we also have integers for how many bullets are left and how many bullets have been shot. Then there are three different states that we have. They're all based on booleans: shooting, ready to shoot, and reloading. We also have separate references. One is for a first-person shooter camera, and we also have the attacking point of the character. For aesthetics, we also have a muzzle flash and an animation display for later use. We also have the sound clips for later milestone for the audio clips. We have when it wakes up, it takes in the magazine size that we were applied to the bullets left, and then we're ready to shoot. We set that to true because we are indeed ready to shoot. So then we go to update. Always, when update is always called upon, it will go for an input based on how we have the shooting. If we are allowed to hold on to the button, we always keep shooting the projectile. If not, then we still do the exact same thing, except it has to be the get key down. If we're allowed to hold on to it, we can just get the key and you can just keep holding it. But if we're not allowed to do the hold and it's just clicks, then you have to do the key down, so it knows that you're pressing it down the entire time. Then once we reach the maximum amount of bullets, then if it detects that we did press the R button and there are bullets and the bullets left integer is less than the magazine size, and it's not in a reloading stage, then we get to reload. And then we also have another if statement if we ran out of bullets completely. Then we get for the reload. This is when you're shooting. We set that to 0 and we keep shooting until we have no bullets. Then it does the performance here. Shooting, ready to shoot, set to false. We have array of array, and we set that equal to the viewpoint array for the first person camera that we have, and we always set a new vector. So what this does, basically what this does is we're pretty much setting an invisible point. Something that the player will not be able to see, but we're basically putting it out there. And when we're doing this, we're basically creating a distance between them. And as a Raycast hit. So what this does is then we're making a target point, and we're placing it at a physics distance, and we're just drawing an invisible line that makes it so that it's basically like a laser point of a gun, pretty much. That's basically what this is doing. We're drawing an invisible dot, and that dot is always aiming based on the camera that we're gonna have, because there's also another thing that we're gonna do that I did for this to be able to show a fluid shooting aspect for the character. And if it's not there, it gets another point. Well, it basically places the target point there. We get a calculation. It calculates the direction from the attacking point to the target point. So we have an attack point object that we placed within the editor, and it's going to basically calculate how far that target point is, and there's going to be a distance without spread vector here. This makes it so that, and the reason why this has been done is so that way we can calculate the spread here, but then we calculate the new direction with spread. That is if the spread is activated. Once we do that, we instantiate the bullet of the object with this script. What this does is once the shooting aspect of it is done, what it does is that it creates a new object based on whatever object we have bullet on, the attack position, this attack point dot position is basically where it is going to spawn in the object, along with the Quaternion identity is where specifically it's going to be. We're adding physics as well to the bullet so that it has a solid, a rigid body, and is able to collide. Once that is done, it makes it so that we normalize the values, and then we make sure that we're adding movement to the bullet. In addition to that, we're also applying an appropriate amount of force impulse. And with that amount of force impulse, we're basically performing the shooting aspect of the character. Then we instantiate amount of flash if we have a flash set up appropriately. And it will decrease the amount of bullets we have left, and we have shot bullets. Then the whole performance resets, so that we're ready to shoot and allow invoke is true, so we're allowed to invoke the shooting aspect. In this module, we have a reload. So reloading is true. We make it a reload time. Once we're done, finished, bullets left is going to be the magazine size that we have set for, and then reloading, we're not reloading. So this is going to be set to false. So all in all, this is basically a small explanation of what we're basically doing within the level. Basically, in layman's terms, for it to be easier to be understood here, what we're basically doing is for the shooting aspect, I have a specific layout for the character. What we have here is I have a couple of different attack points that I have placed here. The gameplay as you can see, there's a lot of multiple cameras that we have here. Well, basically what we have is the gameplay camera is actually this camera behind us. So it keeps following the viewpoint of the character. The main camera would be the camera if we were to be in first person, or if this is the viewpoint of the character. Well, that's not what the values are being taken on. The reason why I placed this main camera is so that we have an appropriate camera that is able to listen to the audio for a different milestone. So what I did here is I placed an aiming camera. This aiming camera is the one that is referencing for the projectile sword. When we have our first person camera, and when we have our attack point, the attack point is this point right here. So once we have the attacking point, and then we have the aiming camera, these 2 points, what it's basically doing here is that when it's like we have a little spring behind us, with that spring, we're basically launching the appropriate projectile that we're going to shoot. So that is what it is explaining here with the amount of the appropriate force. We're basically laying down a line where we're shooting, then we're creating the bullet, and then that bullet's being fired from the camera. That's instantiated in the attack point, and the attack point is basically this point right here. This attack point. That's where the camera is being shot. when it's being shot. Another point that I need to make it clear is that I have made the camera to rotate based on where the mouse would be from here to here, but I'm only doing it left and right, and I'm not using the hovering. I'm not using the part where the object always looks at the mouse, because what that does is if I were to apply the one for if I were to also apply the Y, and then what it would do is that it will rotate as well on the Y-axis part for the object, and it's going to look like we're going to be rotating the whole time. So that is why it will still follow the mouse no matter what if we were to apply the Y. But here I'm only going to use the X, so that way the X-axis will only rotate, so we're only looking from left and right appropriately, and that is the aim for the camera that I'm using. The other aspect that I would like to show, it's pretty simple. Colliders and rigid body. Whoop. So here we have our character jumping up and down. We also have our character that there I showed a different motions of like what happens to the character. Well, right now I'm in the ground, but I think it would be appropriate if I were to reset. I'll explain more about showcasing the enemies, as I do have many enemies in the level, so I'm just going to explain the fact that we are on the ground. Based on what I've already explained for the movement, we're jumping here and we're checking collisions the whole time. If there is a ground, and if they are colliding with any objects, we also have the rigid body on place of the character. So I'm crashing within the wall, it's not going through. We also have the ladder here and ramp, it's always checking that. We're also checking for collisions right here. Made an object disappear. And we have the tree. And here's the difference. Now, I have the detection not only based on colliders as well, but I'm also having the script double checking if there are the appropriate layers masked within the level. Right here I've placed objects here, so it's gonna look janky here with the movement, but it is detecting the collisions appropriately. Now, the reason why this is moving slowly is because I have not these objects were not placed with the appropriate masking of the ground, so the object script thinks that there is no ground here. Once I get to here, that's when it's safe ground. Whoops. And I also have the jump. It's also able to detect the ground. And more with collisions, so I can shoot the bullet and it collides with the wall. The only other mechanic that I have is healing and taking damage. But it's not really a new mechanic in the game. This is just to test out the health bar that I have created here for a different milestone check. And that completes the update on milestone 1.